Hello everyone, in this video we will be talking about kinematics of a particle. So let's get started. So let's say a particle has a path like this, and then we have, it goes from point 1 to point 2, delta s. Now the particle starts here and it's moving in this way. Now the instantaneous velocity is the derivative of s in terms of time, and the average is simply delta s over delta t. Acceleration is the dv dt, and also there's combining these two equations we get a useful equation, a ds equals v dv. Now moving on, so the three main equations that will be used in this chapter to basically get for if we have a constant velocity or constant accelerations are these three equations over here. V equals v naught plus acceleration times s equals s naught plus v naught t plus 1/2 act squared, v squared equal v naught squared plus 2ac s minus s naught. Now those three equations are actually derived from the previous ones. Now let's use those equations in an example over here. So let's say we have a rocket. It starts at position A here. We have VA equals 75 and it's originally 40 meters from the ground. Now we want to know what is the highest, the maximum altitude it's gonna go. So this is where VB equals 0. And we want to know the velocity at point C, which is just before it hits the ground. Now let's get started. So the first equation to get SB, we can simply use this equation over here. Now we know VB equals 0. So we have 0 equals 75 squared plus 2. And the acceleration over here is going to be gravity. So minus 9.8 because it's downwards. Times SB minus 40. Now the only unknown here is SB, thus we get SB equals some sort of value. Now if we want to get VC, we can use this equation over here. Now VC squared equals VB, which is 0. 0 plus 2, and the acceleration is the gravity, minus 9.8. SC, which is 0, minus SB, which is what we get from over here. Now we get the value of VC, which is basically whatever we get over here. So it's fairly simple. All the problems are gonna be like this. You might have to do one equation a step extra to get the value you want, but they should be fairly straightforward. Now let's work a little bit with graph. Let's say we have got a graph of the position in terms of time. So we have here the graph. Now the tangent of this graph is gonna be actually the velocity. It's gonna give us, because v equals the sdt. Now from this we can actually graph the velocity graph. So from that one we should get something like this. Now this gives you the value. For example, this is v1, v2, blah blah blah, and the slope here is gonna be the acceleration. Now we get the acceleration curve over here. Now let's say we want to get the velocity over range of time. It's basically the area under the graph of the acceleration. So we integrate a dt, and for the position we just integrate over v. We get basically that's gonna give us the graph, and then we have this useful two equations over here. Those are derived from the previous equations. Now we're not gonna do any examples on those because they're fairly simple. You usually get the graph and then they ask you to get the delta s or delta v or whatever. Now let's talk about curvilinear motion. So let's say the body is not anymore moving in a straight line as we saw before. Maybe we have a curve like over here. So we have the center O, the radius R, and then we have the V. It's gonna be tangential, and actually the distance over this curve is gonna be the S. So the average velocity is delta R over delta T instantaneous equals dr dt, which is actually also ds dt, and same as before, A is dv dt. Now this is basically the same as we did before, it's just the nature of the motion of the particle is different here. Now let's do an example on this. Let's say we have the trajectory as such. We have y equals x squared over 10, and we have from 0 to 16. Now let's say we want to find the acceleration from this. So first we can get vx, so that's v in the x direction, this is vx, and this is vy. So vx is simply the dx dt. So it's so we're gonna do 2x squared over 10 dt. We get 8, because this gives us 2x over 10. So we do 2 times 16 over 10 equals 8. Oh no, sorry, this is wrong. Actually, it's not x squared over 10. We're gonna have to do, so here x equals square root of 10y. So this goes in here, and then solving the derivative we get 8. Now vy is y dot, which is basically d dt of x squared over 10. Now solving this, what's the d dt? It's gonna be 2x x dot over 10, as you see over here. Now plugging in 2 times 16 times 8 x dot, we got it from before, see here, over 10, we get 25.6. Now the velocity, if we want to know what is the velocity, it's just the square root of vx squared plus vy squared. Now we can plug in the values and we get 26.8 feet per second. Now the acceleration ax is vx dot, it's d dt of 8, so that's the number. This is gonna give us 0, and ay is vy dot, so it's gonna be the derivative of what we got before, which is here. Now solving this, we plug in the values, we get 12.8, so actually the acceleration in this case is gonna be also 12.8 feet per second squared, since the ax is 0. Now this concludes this chapter. This is basically an introductory, and we're going to be using those techniques in future chapters. Thank you everyone for listening.